Grouping Effect for Bar Graph Summarization for People with Visual Impairments, authored by Bonri Kikihi, Masakazu Iwamura, Kazunori Minatani, and Koichi Kisei. Data visualization such as graphs and tables is essential for people's daily lives. However, accessing this information is challenging for people with visual impairments, commonly referred to as PVIs. They often struggle to grasp the content due to the inclusion of detailed numerical information. Sighted people can quickly grasp the overall shape of a graph without needing to check each individual value. We considered that visually similar values could be grouped together and focused on a grouping as a summarization method, particularly when bars in a bar graph are arranged in descending order. In this study, we investigate the cognitive impact that grouping has on PVIs. Data points merged into several groups cause errors compared to the original graph data. This is because some bars grouped will be expressed as a single value. 3 graphs illustrate examples where 10 bars are merged into 2, 3, and 4 groups. We can see the changes that the impression you receive from the graph changes depending on the number of groups. In this paper, we propose error modeling. We defined 3 types of errors. First, the observed error, highlighted in yellow, represents the difference between the original data and what the PVIs perceive. We assume that observed error is decomposed into 2 types of errors, quantization error and cognitive error. The quantization error, highlighted in blue, represents a loss of detail, which decreases as the number of groups increases. The cognitive error, highlighted in red, represents the loss resulting from high cognitive load making comprehension difficult. For the survey, 9 PVIs participated. As the task, participants are asked to listen to an explanation about the bar graphs and recall each value of the graph as a value or ratio to the largest value. The number of bars was fixed to 10, and the number of groups was varied from 1 to 10. We plotted the responses of all participants and created scatter plots and kernel density estimation, which showed the relationship between the number of groups and 3 error types. The observed error, highlighted in yellow, tended to form a U-shape, with the cases of 4 and 5 groups being the smallest for most participants, although this is not clearly evident in the plot. The quantization error, highlighted in blue, tended to decrease as the number of groups increased. The cognitive error, highlighted in red, calculated as the difference between the observed and quantization errors, showing tend to increase as the number of groups increased. From these, we observed the trade-off relationship between quantization errors and cognitive errors.